Blockchain Show is a podcast that demystifies cryptocurrencies and distributed ledger technology.
Welcome back to the Blockchain Show. This is Ethan Kinderconnect here. Today I've got Evan Shapiro, the CEO and co-founder of O1 Labs, the team behind Coda protocol. Evan, welcome to the Blockchain Show.
Yeah, thanks for having me.
Yeah, man, my pleasure. It's really great to connect and, kind of bring some blockchain cheer to our audience all across the world. So before we jump into what you're working on, can you tell us a little bit about yourself and how you came to be involved with O1 Labs?
Yeah, let's see. I guess it's really from like a love of programming and like the technical side of the space. But before this project and everything, I did like an undergrad in computer science, and I always loved doing like lots of different like random little side projects. And I had been following cryptocurrency very, very closely. And I guess ever since like high school, even like I never was really like a trader in the space, but I was always just kind of like following and reading all the white papers and understanding the new technology that was coming out, and just kind of watching what was happening. And it wasn't until around like 2017, like the beginning of that year, my co-founder Izzy had just moved to Berkeley to do a PhD in cryptography. We had known each other since high school. We've been talking about crypto since then, but it was around then that we both started really kind of digging into this technology and understanding where were the limitations, where was like the work that we had both done that he was doing in his PhD that I had done in like my undergrad. Like, how can we think about crypto in like a different way, and how can we contribute ourselves something to the state of the field.
Yeah, I like what you said there. The the limitations were something that I kind of would ponder a little bit, and then it would bring me to think about, the possibilities. And I'm still, I don't know, it's been 5 or 6 years later, blown away each time I have, a new guest on or read something, like a new use case for this technology. Yeah, man, that's really cool. So was he part of your team, or like was he a co-founder, or was that just kind of?
Yeah, both of us co-founded it. After the work we had done that year, eventually turned into us co-founding the company.
Right on. And I know that you graduated from Carnegie Mellon. Was crypto and blockchain something that was only talked about in like the student discussions, or was there any kind of like official courses or mention in any of your schooling?
I don't think there was. I think it was something that like a lot of like us as like students were like, excited about and like talking about. I know like a bunch of my friends ran minors on like their like, desktop computers in their dorm. It wasn't something that ever like, I mean, now it is. I think there's like several courses on it, even just at CMU, at least one. But at the time, no, it was just like us kind of all chatting about it, like, outside of class and stuff.
Yeah, I love that. I love hearing about the early days. It's super, super fun for me to go back and to think about that. After you went to school there, you got your master's. Where was that at?
Also at CMU.
Oh, okay. And I know that you worked as a software engineer for Mozilla. Tell me a little bit about that. How was that? It
was good. I worked on an unfortunately ill-fated project. Ended up being a Firefox OS. But it was really cool at the time. It was my first experience like being in like a tech company, so I got to like see how that all works. And I think I just really like programming, so it was fun to just code up random JavaScript stuff.
Yeah, absolutely. I like Mozilla.
Yeah, that summer, the thing you applied all the random tech companies, or it was for like an internship that with the time when I started working there. I remember like kind of it came down to like Mozilla and some unnamed big tech company, and it was hard. At the end of the day, I decided to do Mozilla. I felt like it was definitely a better culture, maybe, or a project I wanted to support.
Yeah, absolutely. I've been using their browser for a long time, and I'm hanging on to it. I'm trying to transfer over to the Brave browser, but I find myself going back and forth quite a bit. So. They're talking a lot more about, like end encryption, and I've seen some articles about blockchain on their blog and their think they've got a podcast now too, so that's kind of cool.
Yeah, I absolutely love it. A lot of the stuff they're doing is actually putting a lot of this crypto into production. So it's like a lot of actually really good privacy preserving software. I'm big fan.
Yeah, totally, man. Cool. So tell us a little bit about the Coda protocol. Well, maybe before we get into that, as you mentioned, you were a developer. You saw firsthand, Web 2.0 and how all that worked a little bit more behind the scenes than most people. But for maybe some of the folks listening who are just getting involved in the blockchain space, getting their first wallets, it still happens. Maybe kind of tell us a little bit about how the internet works for most people and your vision for Web 3.0.
Yeah, I mean, for sure. So, I mean, if you look at the web today, it's almost like you have like these like walled, like warring states that like you have to like, hand over all your information to. You have to like, really, you don't have much control in that relationship with like, any of these big entities like Facebook or Google or any of them. There's just like these huge big entities that you have to interact with and, have kind of arbitrary control over your data, over your interactions with them. They could change anything they want at any time. And that's just kind of how it is. And I think, like people deserve something better. They deserve something that, actually kind of respects their privacy and that they have like a say in like the tools they're using. And I think that like crypto has a chance of actually making that happen. And I think that, I think when I think about Web3, that's like the thing I'm most excited about is like this possibility of like, I'm going to like have more ownership over, the way I interact with the programs I use day to day. I think it would be amazing, for example, if like Zoom, for example, which is one of the tools we use at our office, is like, for example, they could more concretely and more formally express the privacy guarantees they give and people could understand those better. And if software in general could follow a more kind of respectful user-centric model.
Yeah, absolutely. I know that Zoom was in the spotlight a little bit lately with some security issues, giving data to third-party sites. And there's something that I read about they claim to offer end-to-end encryption, but it's actually like only encryption to their servers.
Right. So there's no way to verify that right now if someone just says that they've end-to-end encryption. But it would be great if you could, actually verify the way the software was running and know that it's working properly.
Yeah. It kind of brings up the whole concept of open source technology and profitability and how you mentioned the internet these days is a lot of like walled off, warring kind of different entities. Do you think that people or like companies are just kind of slow to embrace change, or do they fear not having control over having like a decentralized model? What do you think's like a big roadblock for some of these?
I guess like there's two problems I see. One is like there's the regulations don't kind of meet the needs of like the world we're in right now. Like the regulations lag a lot behind the technology. And the other one is like there isn't really an incentive structure that made sense until recently with crypto that like could allow for a decentralized architecture to exist that would actually have everyone aligned in the right way for incentives. Like, if someone's like, I'm going to make a decentralized Twitter or Facebook, it's like, great. Like, where's your incentive to hire, thousands of engineers to like make that happen? It's that's a really hard problem. And capitalism solves the allocation problem, but it doesn't solve like aligning the projects with their users. Whereas I think with some like new technology like crypto, we actually have the chance of having new entities that are aligned with the users and still have the incentives to like, have, larger organizations of engineers and people that are working on the projects.
Totally. Yeah, that makes perfect sense. I think that, we're starting to see more and more projects come out that are gaining more and more momentum, starting to see more references of cryptocurrencies and blockchain technology and TV shows. I haven't really seen any movies with it that I can think of. Yeah, man. So tell me a little bit about Coda and how you guys came to the vision of your code.
I guess like it was just at the stage. It was like in 2017, like early that year, and we were like both watching like the rise of Ethereum, and like there was so much hype at the time around the way this technology is going to be world changing. But we saw that hype and we looked at the technology itself and we were like, well, this does like 3 TPS for like Bitcoin. There's probably going to be like this massive war later this year about even to change that. The hype is real, but like the technology doesn't really match it yet. And we started, I guess, like, so kind of as going into our own kind of thinking around, well, what is the technical limitations of this technology right now? Where do we want it to look like? And then we just spent a lot of time thinking about this problem of verification, because the way we were thinking about it was it's really important that everyone who uses the software is able to verify what's going on and participate in like knowing the rules are being set the right way and in setting those rules. And that's not really a property that you get with a traditional blockchain, because you have to download and check the whole blockchain if you actually want to use it. Which means that for most users who can't download hundreds of gigabytes, you have to outsource that to some other entity that you end up trusting. So it creates like this like hierarchy of like individuals in the ecosystem, which is bad, and it means that people can't just use the software, which would be the best thing ever. And at the time, Izzy was learning about ZK snarks through his PhD, which are basically a tool that allows people to very cheaply verify what would other be very expensive computations, and in the process hide some data like they do in Zcash for privacy. And so we made this connection that instead of needing to download a whole blockchain, what if you just could download a little zero knowledge proof, and that zero knowledge proof attested to the validity of that whole blockchain? So with that, we could build a blockchain that's extremely lightweight and could have a lot of participation and a lot of easy access. And that eventually became Coda.
That's awesome, man. I think that, when you're talking about Ethereum, back in early 2017, that was kind of a big impetus to this podcast. We almost named it the Ethereum Show, but we weren't quite positive that, that was going to be the one and only, that would dominate. So we went with the Blockchain Show, and, it kind of brought up the whole issue of scalability, right? So we thought, this is a great thing, worldwide computer, but is it going to work? We kind of followed it for a few months, and then we saw it, it had some challenges, some growing pains, but this brings me to my next question for you is, the S word, scalability. Why shouldn't we measure it only by transactions per second, and what are some other, important factors to consider?
Yeah, it's kind of funny, right? Because like, the way I think about it is it's kind of like you have like this tension between like scalability and like accessing and the chain being decentralized. Like we have like a very scalable computer, but it's called like a database, and like it's not decentralized at all. On the other hand, we have a very decentralized computer. It's called Bitcoin, and it's not that scalable, at least not yet. And if you require everyone to download all the transactions that have ever happened, the more you scale the chain, the harder it's going to get to download and use the full node, to use the chain in a trustless way. So if you talk about scalability only in terms of TPS, you end up doing is there's like the trade-off between decentralization and scaling that you have to have considered, and you kind of lose a little bit of that, which is we think unfortunate. The way I think scalability should also include is like just like the number of nodes in the network. How easy is it for me to turn my phone on and join a protocol like trustlessly, or my browser to like go to a web page, and that web page to fully verify like a blockchain? If that's like a few megabytes, that's great. If it's a few kilobytes, even better. If it's hundreds of gigabytes, maybe it's scalable in the TPS direction, but it's not scalable in like the accessible decentralization direction.
Yeah, I like that. That's very well said. Maybe you could tell us a little bit more about how Coda works, kind of behind the scenes, like about the Genesis token program, what it's going to achieve, and maybe some incentives to potentially get our listeners involved.
Yeah, for sure. So it is a protocol which, like I've just been kind of talking about ZK snark. So it replaces the blockchain with a ZK snark, which means that to fully verify it, you can do it from your browser, from a phone. It just kind of works from everywhere. In a way that's fully trustless and doesn't require like Infura or like MetaMask or really any intermediaries that would otherwise have to exist in order for you to access the chain. And it's awesome because like it means it's super easy to join as a node operator, and it's like going to be super easy to develop for as a developer, because your client's devices can directly access the blockchain instead of having to go through some intermediary that has downloaded it already. In particular, like right now, we're trying to like bootstrap our node operator community. And one thing we're doing there is this is like during our testnet phase, which is going on right now, is we are basically in giving grants out to people that are willing to run nodes on mainnet. So this is like our Genesis program. So if you're interested in like joining like a pretty technical and like robust community about ZK snarks and consensus and like testnets, you can check out the program we have there. It's like a fairly substantial grant we're giving to 1,000 people for mainnet. I forget how many. At one point, I calculated how many 2080 Ti GPUs you would need to have an equivalent percent of Ethereum's consensus, and it was something like 200. But I'd have to go double check that now. But yeah.
Okay, cool. Yeah, I like that incentive. Just to go back a little bit, you're talking about ZK snarks, something we haven't really talked about before. So, to some people listening, the blockchain is still, like a vague term. Like my mother-in-law, she's a retired nurse, and she's just starting to understand how some companies are using blockchain to revolutionize healthcare administration. And so how would you do, first of all, when people think of the blockchain, it's not quite like one thing. That's what I try to tell people. It's like there's like different versions, right? So maybe you could just break down a little bit more, how you're able to utilize ZK snarks, a little bit how it differs from maybe the traditional, I don't know, I guess people would think of like the Bitcoin blockchain if they're new to this space, and just how it's able, the Coda blockchain is always able to stay the same size, like about 20 kilobytes.
Yeah. So yeah, it's funny. It's like, I think that like blockchain is to like the general audience as ZK snarks are to like the crypto audience in some ways. Maybe people are a little more aware, but ZK snarks are fairly new, even in crypto, even though they'll, I think, be a major component of the system because, so I guess ZK snarks let you do really two things. One is they let you prove that you've done computations that match a certain set of requirements while hiding some of the steps or some of the inputs. So I can prove, for example, in Zcash that I've made a valid transaction, even though you don't know who the sender, the receiver, the amount is. You can just hide all the data. You can hide the transaction. So one thing is privacy. You can do that for like really anything. You can always prove things in a privacy preserving way about the way you've done a computation. The other thing it lets you do is it lets you quickly check a very large computation without having to do the computation yourself. And where that helps us with Coda is usually in a cryptocurrency. Using a blockchain requires downloading and checking the whole chain, which everyone does independently. They have to if they want to know it's done correctly. But that's a very big computation and a lot of data to download. What you can do with a snark instead is you can have a snark which represents the computation of downloading and checking the whole chain. And the snark can say, if you were to download and check the whole chain, you would come up with this final state for the chain, and that state followed all the rules of the protocol, which is the same thing you would check normally, but instead of everyone having to do it independently, everyone just checks the snark, and the network together updates the snark. Does that make sense?
Yeah, that makes sense. Thanks for explaining that. And, just to go back to, the Genesis program, what sort of hardware would somebody need if they wanted to potentially start a node? I
mean, any laptop or desktop should be good enough. It's pretty resource cheap as long as you're not on like a Raspberry Pi or something. And it also, works on the cloud, obviously, too.
Cool, very cool. And just in case anybody wants to get involved with, like, what's the website, or how would they do that?
Codaprotocol.com. And the two things I would check out there are both like the Genesis program itself and like our Discord. Our Discord is like super active. There's a lot of people already that are participating and like chatting about the protocol. And I think both of those are good places to check out what we're doing in the community.
Right on. Yeah. So if anybody's listening, definitely check that out if you'd like to get involved. Just to kind of pivot a little bit back to our earlier conversation about decentralization, how we can attain it. And, I think it's important to achieve it without sacrificing security, kind of like what you said. Now, I was earlier, just before I was talking to you, I was just kind of surfing the internet, looking up, when we're going to get our checks from the IRS for this stimulus package in America. And one of the things that struck me was that the IRS is setting up a database on their website where people can upload their bank account routing information to get direct deposits quicker. And I almost like smacked my forehead thinking like, holy crap, that's like a gold mine if someone really knew what they were doing. I'm hoping maybe you could talk a little bit about, just to kind of tie it into this whole global pandemic thing we're going through. You mentioned Zoom earlier. A lot of things are shifting onto the internet in like huge waves. When you envision the future of conducting our lives online, how do you think we can do it decentralized without sacrificing security?
I think this is like the question to ask also, because like I think that like as much as we're starting to see this happen now, it's just only going to happen more in the future, like as machine learning and other technologies get more powerful. But yes, to go back to answer the question, I think like the way we think about it is like the only real way to like kind of improve the power asymmetry here is to use cryptography. We think cryptography is like a very powerful tool towards like giving actors oversight and accountability and privacy over different things they're doing. And snarks are like an extremely powerful tool in that toolbox. So we're extremely excited about snarks because in the example you just mentioned, the bank could, you could run some. This would be in some future, right? But like you could run some program on your computer that you enter your bank info into, and that you're doing it safely into that program, and that program can like talk to the IRS and make sure the IRS is sending that money in a way that's safe without the IRS actually learning your routing number and stuff. This would require, some other probably tools to be developed in, the financial system in general. But the idea basically would be like, you can prove things about like, hey, like I'm a unique person. Here's my unique bank account. I'm not like trying to Sybil attack the IRS, and the IRS can trust that without having to like see all of your information itself. And this is good both if you're like actually worried about your privacy, and it's also good if you're like someone that like the IRS that doesn't want to have probably like this big burden of having like this sensitive data on their own machines. So I'm hoping there will be like an alignment of interest there that will. Anyway, yeah, that's how I would think about it. That's how I think about it.
Yeah, that's a very, very good way to put it there. And now I understand how you're able to facilitate thousands of downloads a second. But something that struck me was being able to store years of transactions and millions of users. Is that just a function of your protocol and like the Z-snarks, or is that? Or I guess what I'm trying to say is like, does it matter how much data there is? Is it all going to be 20 kilobytes no matter what?
So yeah, the proof at the end of the day, the proof of like the final state that says like, that proves that your account balance is a certain thing, that's always going to be 20 kilobytes. If you wanted to look back and see what your transaction was like 10 years ago, you'll need to look back and, look at that data. But most users don't end up doing that in their daily lives for, either the state of their computer 3 years ago or the state of their bank account 3 years ago. What really matters is like the current state, and the proof like attests to that. Absolutely.
All right. Awesome. And I'm sorry to keep going back here, but just in case anybody doesn't understand zero knowledge proofs, maybe you could just expand a little bit on that and the benefits of that.
Yeah, for sure. I kind of mentioned briefly like a super high level before, just some things they can use for, but let me explain like a little more like detailed now. Let me give like a really, really, really lightweight analogy, and then I'll give like a more formal analogy that like hopefully will still be followable, but maybe be a little technical. So let's say that I wanted to prove to you that I have like, a giant tree in my backyard. One thing I could do is I could take you to the tree and I could show you the tree, and or I could drag the tree to you or something. Another thing I do is take like a photo of the tree and I could send you the photo. So the ZK snark is kind of like that photo. Instead of having to like actually show you like this huge thing, I can prove you it exists by just like taking a photo of it and giving you the photo. A snark kind of does that, but for like a computation, not for like a physical object. So you can imagine that I could be over here. I have my supercomputer or whatever. I don't, but someday I wish. I run some huge computation that takes like 1,000 years to run. And then someone else comes along, you come along and you ask me, well, what was the result of that computation? I tell you it was 4. And you're like, how do I believe you that it's 4? And I'm like, well, I ran the computation. What do you want from me? You should run it yourself if you really want to check. That's the world before ZK snarks. The world with ZK snarks is I do this huge computation on my supercomputer, and I produce this snark that says, hey, if you had this supercomputer, if you were to run this huge computation, you would also get 4. Here's like a proof that you would get 4. And you can check that proof very, very quickly. You can check it in milliseconds. You can check it with a few kilobytes of data. That's kind of what the snarks do. They let you produce these proofs of a big computation that you can check really quickly. And you know that if you had run the computation, you'd get that result. And it also lets you do some things where you hide the inputs. So I can say like, hey, like one of the inputs was 3. I'm not telling what the other input is, but if you had 3 in that other input, you're going to get 4. And I can prove that there existed some input such that you would get to 4. And that's how you can do privacy preserving stuff as well. You can say like there existed some data such that there existed some set of votes such that all the votes were signed by the people in the US such that the result of the election was X. So you can hide data, and you can also have a proof that the computation was done correctly.
Wow. Yeah. Awesome, man. Thanks for breaking that down. I think it's very helpful to.
Yeah. They've been around for a while, like as a theoretical construct and as like less practical construct, but it's only they've become really plausible, like practically in the last few years. So, it's still relatively new. So it's like when public keys came out or hash functions, it's like a new primitive to learn.
Right on. Yeah. And it kind of reminds me of like back in the 80s, how there was like the media wars between, like VCR and Betamax. And, a lot of people bought both for a while because they weren't sure what's going to come out, or, like Blu-ray and HD DVDs. Do you think that in the future, people are going to have to just kind of like switch between blockchains, or are we going to eventually, or protocols, or are we going to have some, like, is one going to win out and become a standard, or do you think we're going to have some sort of Oracle programs to communicate? Like, what do you think that ultimately the future of 3.0 will look like on a technical level?
I think that there will be a lot of blockchains, but I don't know if it'll be any of the blockchains that are out today. I think that a lot of the new protocol work that's happening improves a lot upon the existing protocols that exist, and that some of the existing protocols I think have enough momentum where they'll probably be able to evolve themselves the way that Ethereum is doing towards being relevant in that future. But there's other chains that won't evolve, and there's some new chains that will come along. I think there will be a lot of chains. I think it'll probably be like a power law, but it remains to be seen how good the interoperability is between different networks, and what kind of network effects become more important. Yes, that's what I think.
Yeah. Okay. I agree with you there. Digital assets are pretty much the most prevalent, thing, for lack of a better word, that I think of with the Coda protocol. But what are some other use cases that people might use your program for?
The one I'm most excited about right now is just participation. I think it's a really powerful concept for everyone to be participating in a chain at the consensus layer. One thing I didn't mention before about the Genesis program is we set the proof of stake up so that we can have an uncapped number of participants, basically. So I think just being able to participate and kind of jointly govern a chain is really exciting. Kind of in the direction you're mentioning. The other thing I'm really excited about right now is the possibility of tokens for the world. I think if you're Twitch or Reddit, it's possible to deploy your own token. That seems to work pretty well for those platforms. But I think tokens in general are a really powerful concept, and I think there's a lot of opportunities there, especially when you have a protocol like ours where you can just really easily build your program directly against the protocol itself instead of some third-party service. It really improves the abstraction. You don't have to daisy chain all this stuff together to build anything. And then I guess beyond that, I'm excited also about the possibility of snarks for verifiable programs, for basically provably fair platforms. So it'll also be really easy to build with snark technology on Coda. And I hope that'll make it so people are able to build platforms that have incentives but are also provably fair, or provably continue to follow their own rules in any case. And you can see what those rules are. Very excited between all three of those. Yeah.
Yeah, man, that's really great. I saw something earlier about, obviously there's the Coda protocol, but there's also Snarky. And is that just baked into Coda, or is that its own separate entity?
Ish. So Snarky is like a library made to make it possible to make the huge snark used in Coda. I said before, like the snark represents like the computation of checking the blockchain. So basically, the whole protocol is in a snark. We needed to have a good way to write snarks really efficiently. So we made this programming language called Snarky, which lets you write snark programs like it was like regular code. Before Snarky, it was writing like a snark program was closer maybe to like designing hardware or doing some math problem rather than like actually just writing code. And so Snarky is like our approach at making that possible. So Snarky we use to write Coda because the whole protocol is written in Snarky, but or I should say like the snark component of the protocol is written in Snarky. But Snarky can be used for other things too. We've written like little toy examples of like voting bots or not voting bots, but like verifiable voting programs that preserve privacy and stuff in Snarky as well.
Awesome. I was looking at the proof of work blockchains, how it's in excess of like $2.5 billion per year, and Coda Networks it's got to be like a fraction of that because like a traditional blockchain is going to be like over 2 terabytes and increasing. But since yours is fixed at 22 kilobytes, that's just going to greatly diminish the energy usage.
Well, yeah, we hope so. So we both, I think proof of work is like, it's like who can gobble up the world's energy the fastest. It's like this like ecological like and like kind of like it's really bad. As well as like the requirement to like make everyone's computers like have crazy amount of space and crazy amount of download to download these big chains. So yeah, I hope that like it will actually have a much more green footprint. Yeah.
Right on, man. And just to play the devil's advocate here, because there's always someone in the crypto community who's like, for instance, like a Bitcoin maximalist who thinks that's like the only blockchain, or everything else is not like a true blockchain. Like what's some of the criticism that you guys come across in the way that you're going about this?
I think the most, sorry, go ahead. Yeah.
Oh, and I was just going to say, like, is there any basis to that, or is it just like hating,
I think the biggest criticism, or like the biggest one we get that I think I'll talk about it like this, is like that proof of stake versus proof of work. That proof of work is way better than proof of stake and way more secure and way more understood. I think that the problem here was like proof of stake is like, it means like, dozens of different algorithms. It doesn't just mean one algorithm. The variant that we've gone with, basically with proof of stake, you can sacrifice the number of participants for instant finality. We've chosen proof of stake where we can have an uncapped number of participants, but it's still probabilistic finality. So it's the same probabilisticness as Bitcoin, but we can have proof of stake with a lot of people in it. The other complaint that I think about a lot, I don't know if we actually get this one that much, but I think about it a lot, is like proof of work is like a brilliant mechanism for like onboarding people to a protocol. Like if you want to join Bitcoin, you just turn your computer on. At least that you could do that a few years ago when we were in college and stuff. But proof of stake, it's not really the same, right? Proof of stake, you have to like have a lot of capital. You have to like make the decision to invest that capital into a protocol. We hope that one thing that'll help here is we have a part of the protocol called snark mining. We have to produce snark proofs for the protocol to be really small. And we have like part of the protocol is like if you produce snark proofs, you can get paid out for doing that. So we hope people can still turn their computers on and get some Coda that way, even though it's a proof of stake for the consensus layer. So I guess I mentioned a few things, but it's definitely like a tricky, like heated topic for sure.
Yeah, absolutely. There's like I don't know what to call it, like crypto tribalism. There's different schools of thought, and I think that as we progress through the years, it kind of gets more and more narrowed down into basically like what works and what isn't going to work so well. So,
Yeah, it's a great thing about tech. Like at the end of the day, hopefully it'll be obvious what works and what doesn't.
yeah, man. Well, it's been really, really great having you on the show today. I appreciate your knowledge and insight into the space. It's really fun just to kind of geek out and learn new things here. I try to make these questions kind of accessible to everyone, and in the process, I think I kind of maybe I portrayed this towards like beginners, because we've been getting a lot of questions about, can you make it more relatable to the newer audience? I think you did a really good job of breaking that down, man. So I just want to thank you again for coming on the show and give you an opportunity to give us any closing thoughts and ways to connect with you.
Yeah, thank you for having me. It was fun. I think if you're curious to learn more, check out our website. Like I mentioned before, I think our Discord community again is like a fun place to hang out on. Definitely like everyone spanning the from researchers to like people that are new to the space. We're working hard to make it a really acceptable community. So hope that if you check it out, it'll be cool. And then if you want to reach out to me, I think like Twitter's probably the best. Twitter or Discord, I guess. But yeah.
All right.
But yeah.
Cool, man. Well, Evan, thank you so much for your time, man. Again, it was a real pleasure talking to you.
Yeah, thanks.
Thank you all for listening to this episode of The Blockchain Show. My guest today was Evan Shapiro, the CEO and co-founder of O1 Labs, the team behind Coda Protocol. Man, that was a really good episode. I want to thank Evan for taking the time to be on the show with us and explaining things to me like I'm 5. Sometimes it's good to go back to basics. I hope you guys got something out of that. I know I did. This show started out as a way of my friend Steve explaining the technology to me and eventually Sarah. And as time went on, Steve left, and then we got Mark and Ian, and then they left, and then Steve came back, and then Steve left again. I used to be so worried, like I don't know enough to keep this show going because I'm no expert. But then I started to think about it and listen to some of the old episodes, and I thought there's value to learning from experts. And if you've been listening, to the show since, January, I've been having a lot more guests on who know way more than I do. And I think just trying to humble myself and learn as if I'm a beginner. There's a lot of value to be gained just from starting out in a kind of like at a student mindset. So let me know what you guys think. Send me some emails, info@theblockchainshow.com. I'm trying to set up my own email eventually. It's not there yet, but I'll let you know when that comes. It'll be ethan@theblockchainshow.com, but that's not set up yet, so don't send anything there yet. If you'd like to hear more guests like Evan, or if you would like to get Steve or Mark and Ian back on, let me know. I'll see what I can do. If you've listened over the years, we've tried to have sponsors and advertisers on the past to keep the show going. Haven't had too much success with that. There's the whole integrity issue of, do we want to sell time on the show? And I think I'd rather it be kind of more merit-based, give people an opportunity to donate if they'd like to. I don't know, it just kind of gets weird when it's pay to play. It just seems ingenuine. For now, I'm just donating my time and money to keep learning, because I think that we're at an interesting time, kind of like an apex, where we're seeing this technology really take off. And I always had this fear of big corporations using it against us. I don't know, that's probably like, not far off from what could happen, but I like to try to find just people who are using the technology just to help people. There's always the good side, the dark side. There's something to be gained from learning about either. Anyways, I'm sorry that I rambled here. I wanted to just give you guys an opportunity to connect with me. You can go to our Facebook page. You can go to us, check us out on Twitter @blockchain_show, or connect with us on minds.com. I know they're doing a lot on that platform to try to decentralize how we go about our social media lives. We got a page there and a channel. Or you can find me on mine's. It's at KinderConnect, KinderKnecht. We do have a Telegram, but I don't really check that. Our YouTube page is pretty much shadow banned, but there is some videos there, mostly audio. Other than that, grateful for all of you for downloading the episode and sharing it with your friends. If you would be so kind to give us a kind review on Apple Podcasts or wherever you get this episode, it goes a long way into helping other people find the show. Again, and if you have any criticism, constructive or otherwise, go ahead and send it to the email rather than the reviews so we don't scare off any potential listeners. It gives me a chance to implement those changes to make the show better for you. Thanks again for listening, and I hope you have a good rest of your day, whether you're quarantined or ordered to stay at home. My heart goes out to you. Feel free to connect if you would like to be on the podcast, or if you know someone who's an expert in the field that would make for a good guest. That's all is welcome. So stay safe out there, everybody. Goodbye.